Hi Guy, I'm Laurie from AI Elephant.
Hi guys, I'm Leo.
We all know Jensen Huang as the pickaxe seller of the AI era, but today, we're not talking about how many chips he sold. We're talking about what he saw before anyone else.
Exactly, Laurie. In the PC era, everyone believed in Moore's law. CPU was king. So how did Jensen dare to question that truth back in 1993 and end up building a completely different world of computing?
That's the core of today's story. First principles thinking. Jensen foresaw the limits of Moore's law, invented funty-tuberated computing, and, through a major cognitive leap, built what we now call the trillion-dollar subterry. In this episode, we'll explore three themes: his cognitive leap, the engineering moat, and the trillion-dollar future markets. Let's go back to the beginning. Jensen Huang was among the first to realize that TV general-purpose computing was losing efficiency. CPU performance was slowing down, while the problems humanity needed to solve were growing exponentially. The scaling of transistors would eventually hit a physical wall.
So his conclusion was that we needed special accelerators to help CPUs handle the heavy lifting.
Exactly. He believed computing must be safety-coupled, different tasks handled by specialized processors. As he often says, the future of computing is accelerated computing. That principle became the foundation of Nvidia's philosophy and planted the seed for the AI revolution we see today.
Nvidia's early struggle was a classic catch-22. No applications, no platform, no applications. Back then, GPUs were graphics cards. No one imagined they could power scientific computation.
Sounds like every startup story. How did they break the cycle?
They started with gaming. Jensen realized that asterisk 3D graphics are just physics simulations and linear algebra. By mastering these fundamentals, Nvidia built a software stack capable of real computation. In 2006, they launched the CUDA, a framework that allowed developers to use GPUs for general-purpose programming. From that point on, the GPU was no longer a graphics tool. It became a universal compute engine.
So CUDA was the turning point from a graphics company to a computing company.
Then came 2012, the year deep learning exploded. AlexNet, powered by GPUs, crushed CPU systems on ImageNet. Everyone thought this was about machines recognizing images, but Jensen thought deeper. Asterisk. If a system can recognize cats and dogs, what else can it learn?
So it wasn't about the application, it was about the principle behind it.
Exactly. From first principles, he saw that neural networks are CUDA universal function approximator C. They can learn Houdini input-output mapping. From vision to code generation, from weather prediction to drug discovery, any function we can describe can, in theory, be learned by deep learning.
So Nvidia suddenly realized they weren't just holding a faster graphics chip, but a key to redefine the entire computing stack.
Exactly. That was their true cognitive leap. From selling hardware to building the foundation of intelligent computing.
In 2016, Nvidia launched the DGX-1, what Jensen called the world's first die factory. In his words, an AI factory is not a lab, it's a production line. The raw material is data. The output is intelligence. Every model trained is a new product built.
That's a great metaphor. But couldn't any company just stack up GPUs and do the same?
That's the difference. CUDA design. Nvidia doesn't sell parts. It sells UNDI systems. Every layer chip, software, network, and storage is co-designed to function as a single intelligent engine. This vertical integration allows performance to grow tenfold each year, far beyond Moore's law.
So it's not just about power, it's about harmony, efficiency, and orchestration.
Exactly. Jensen even proposed a new KPI. Throughput per unit of energy efficiency itself became the ultimate technological moat. The first trillion-dollar opportunity is Thevan digital labor. AI is no longer just a tool. It's becoming a form of labor. Each model is a digital employee that can write code, analyze data, and automate tasks.
So in the future, companies will manage both human and AI employees. That's wild.
That's right. Jensen predicts that every company will one day have its own sovereign twin AI factory, producing intelligence for its digital workforce. AI will not consume resources. It will generate value. The second trillion-dollar market is Crestwine embodied AI. Jensen believes intelligence will eventually inhabit every moving object: robots, drones, cars, even industrial plants.
But going from the digital to the physical world seems nearly impossible. How does Nvidia plan to bridge that gap?
The answer is Sabdi Omniverse, a virtual world built for robots, grounded in real physics. Jensen says, robotics needs 3 computers, one to control itself, one to learn in simulation, and one to run in the real world. That middle computer is the Findi Omniverse.
So it's like giving robots a virtual sandbox, where they can fail and learn safely before entering the real world.
Exactly. It's a simulation-first approach that dramatically accelerates the path to embodied intelligence. To wrap up, Jensen Huang's vision spans 3 great leaps. 1. 2 cognitive leap. *** from Moore, S-law to accelerated computing. 2. Engineering leap, *** from GPU to the AI factory. 3. Economic leap, *** from compute power to digital labor.
And in 2024, he introduced the idea of sovereign AI, the belief that no nation can outsource its data, models, or intelligence. In his view, every country will need its own national AI factory to safeguard its digital sovereignty.
Exactly. Jensen isn't just selling chips, he's selling the blueprint for the world's next computing civilization. Thanks for listening. See you in the next episode.